A very good morning, one and all. Myself, D.Jyothi, Assistant Professor, Department of Data Science, MLR Institute of Technology, Hyderabad. I'm handling the subject data analytics using R. This is the second session in this subject. So, today we are going to discuss about the special numbers, changing classes in R programming, input in R, output in R, inbuilt functions in R. In special numbers, we have the infinity, negative infinity, NaN, not a number, and not available. These are the special numbers. And infinity, it will be represented by INF, or it will be represented by 1 or 0, and it is used to represent only the positive infinity. Whereas the negative infinity, it can be minus INF, or it can be minus 1 by 0. It is used to represent the negative numbers. NaN is not a number, so we'll be using NaN notation. NaN will be used as a keyword for this one, and it will be used to represent undefined, unrepresentable values. For unrepresented values, we'll be using NaN. And Na not available, when the data is not available, when we have the missing data, Na will be used. Na means not available. Changing classes in the R programming. In the programming, sometimes we need to convert one data object into the another data object. For that, we'll be using the as function. The as dot functions are used to, so it will be doing the coercion in between the different data types. You can convert a numeric into a character, or character into a numeric, like that. So it is an example, converting a numeric into a character. Here you are taking a numeric value 1, 2, 3, and you are using as dot character of x. What is x here? In x, 1, 2, 3 will be stored, and these 1, 2, 3 will be converted into a character. Next example, we will be having converting a character into the numeric. So you are using a string here, because you have the number in between the double quotations. It will be considered as a character, and you are using the as dot numeric function. This value will be 4, 5, 6 value will be converted into the numeric value. And you have the as dot date functions to convert a character or numeric vector to a date object. And this is the function we use. This is an example. You are taking a string date, and this string date will be converted into the date object by using as dot date function. And next, you can convert, you have the matrix function. When you want to convert a vector into a matrix, then you have to use the matrix function. And you have a vector here. This vector is having the values from 1 to 6. And when you use the matrix, and you are specifying the vector here, and you are specifying n rows are 2, n columns are 3. These 1 to 6 values will be arranged like 2 rows and 3 columns. Your values will be assigned in the column format. When you specify n row equal to true, then only the values will be taken in the row format. Otherwise, by default, column wise values will be taken, and the vector from 1 to 6 will be converted into the matrix. And we have the input output functions. So you will be having a scan function. It used to take the data from the user at a terminal. You want to take the data using the objects, and you will be having lot of R objects are there. You can take the data from a vector or list, matrices, arrays, factors, and data frames. So when you want to take it from a terminal, you have a scan function. And when you want to take the data through a R object, these are all the options you have. Vector is there, list, matrices, arrays, factors, data frame. Output in the R, they'll be using the print function. So problem with the print function is it cannot combine 2 or more strings. So for that, we'll be using the cat function. It is an alternative to print function. You can use multiple strings here in the cat function. Inbuilt functions in R. The function, you are having For the basic operations, you have all the mathematical functions: addition, subtraction, multiply, division. Exponential, for exponential you have the two symbols. You can use either this symbol or this symbol, and this is for the modulus. And next you have the trigonometric functions: sine function, cos function, tan function, inverse sine, inverse cosine, inverse tangent function. And you have the logarithmic functions and exponential functions in the mathematical function. The exp is used for the exponential, and this is log function is for natural logarithm. Base 10 logarithm log 10 function is used. Base 2 logarithm log 2 function is used. You have the statistical functions: mean, median, standard deviation, variance, and sum. These are the statistical functions. And you have some more mathematical functions: absolute, square root, ceiling function, floor function, and the factorial function. And for the random number generation, runif function will be using. And for the normal distribution, R norm function is used. For the Poisson's distribution, R POIS function is used. This is an simple example how you can do a simple calculation by using the built-in functions. Here in the question, calculate the 10 base logarithm of 100 and multiply the result with the cosine of p, cosine of pi. And here they are giving a hint also. So in the answer, look at in the answer, you have already log 10 function is there. So what they are saying, 10 base logarithm of 100. So this is a 10 base logarithm and you have a value 100. And next what you have to do, you have to multiply. You are using a multiply symbol here, and you have to multiply it with cosine of pi. You have a cosine function already and you are using a pi value here. So you will be getting the answer as -2 for this one. So like this, you can simplify complex mathematical equations by using already built-in functions available in the R programming. With the help of that functions, you can do these kind of problems very easily. Thank you.